Okay, we're going to continue on 3.4's notes. Now we're just going to talk about that discriminant, which was what was under our square root. It was the b squared minus 4ac. Okay, because if you remember the quadratic formula, it's negative b plus or minus the b squared minus 4ac, and everything's over 2a. It's just what's under the square root. Now, this does not solve our quadratic. So if it says solve the equation, you have to use that entire formula. So just try to do it by the discriminant. The only thing, if we just look at the discriminant, it is going to tell us if we have two real solutions, one real solution, or two imaginary solutions. Okay. So we're going to have, if you type in your discriminant and you get a positive number, just like we did on all three of these examples. Okay. Our discriminant was 1, 12, 121. Okay. They're all greater than 0. Tells us our solutions are going to be two real. I can't even talk. I'm sorry. Two real solutions. We got two real solutions here. We have two here because of the plus and the minus. 2 plus square root of 3 and 2 minus square root of 3. And we had 2 here. Now, if these would have been equal to 0, I would have had only one real solution because that vertex is actually on the x-axis, which means that's the only point it is going to touch that x-axis. Okay? If it doesn't touch the x-axis at all, which means my discriminant is going to be less than 0, then we're going to end up with two imaginary numbers, which just means our square root is going to be negative, so we take out an I. Okay? So, it might be something like 2 plus or minus I squared of 3, or it might be negative 2I, okay? Stuff like that. That's when I is there, it means we did not intersect that x-axis at all. All right, so in these problems, we're just going to use that discriminant and determine what happens, how many solutions and what type of solutions they have. Okay, so b squared plus 34b plus 289. I know that a is going to be 1, b is 34, and c equals 289. Okay, and I'm just plugging them into the discriminant, which was b squared minus 4 times a times c. So I have 34 squared minus 4 times 1 times 289. And so I get 0 when I type that in. And then I need to compare it to 0. Is it equal to, less than, greater than? Obviously this one is equal to, which means that vertex is on the axis. So there's, on the x-axis. So there's one solution, and it will be a real number. Okay. Now, number 5, I did it equal to 0, so I'm just going to move that x squared. So I get 0 equals negative x squared minus 8x plus 3. Notice I wrote it in order from degree. So that way my a, b, c is also in order. So I have a is negative 1, b is negative 8, c is 3. And then I plug it into the discriminant. I have negative 8 squared minus 4 times a, and times c. In this case, I get 76. That is greater than 0, so I will have two real solutions. Okay. Again, get this one equal to 0. I'm just going to subtract the 3q, so I have 4q squared minus 3q plus 1 equals 0. A is 4, b is negative 3, c is 1, and I plug them into the discriminant. I have negative 3 squared minus 4 times 1. You get negative 7. That is less than 0, so this won't touch my x-axis at all. So I will have two imaginary solutions. And you should be able to tell that just by when you are using the quadratic formula and you type in everything in your calculator, and you know a negative 7 is in your square root, and we can't take square roots of negatives without making them imaginary. So that's all these are stating, okay? Is that when you do that step, when we did the quadratic formula before, and we took square roots, when we did this step and found this number, if you can take a square root of it, you know you have two real solutions. If this was negative, I can't take the square root of it. I'm going to have an imaginary number, okay? That's where the I comes from. If I do the discriminant and I get 0, it's going to be some number plus or minus 0 over some number. Well, that makes the plus and minus kind of go away, and I have a number over a number, and that's how you get one's real solution.